All right, welcome everyone to episode number 5, I think it is, for Flight School. I'm David Espejo, I'll be your host today, and I'm really glad to be here. If you're watching us from live stream, feel free to leave a comment where you are tuning in from. I typically do this because, yeah, it's interesting and probably a conversation starter. Um, I'm joining from Pereira, Colombia, from sunny South America. And yeah, feel free to leave your comments right there. Today we'll be focusing more on hands on content. Let me share my screen real quick here. Yeah, my entire screen. Why not? Cool. So yeah, today we will be going through a live deployment or a deployment of Flight on two different environments, and we will do it from scratch. So yeah, I'm kind of paying my bows to the demo gods for this to work as expected. But if it fails, it will be also an opportunity to learn collectively. Feel free to ask questions. I'll try to handle them at the end, or if something really important arises, we will cover it right away. But this is your session, so feel free to ask questions. Cool. So yeah, we'll take a look at the different deployment paths right now for Flight, and we'll go through deploying Flight on a self-hosted Kubernetes environment. Self-hosted, I mean it's a cluster running on-prem, no cloud, no managed service, and also Flight on AWS, right? And some of the next steps after deployment. Cool. So I'll start by mentioning Union AI, who's not only in sponsoring this live stream and the episodes Flight School, but Union also offers the managed service, the managed flight service, which is very interesting because you don't have to deal with anything of what we will see here right there on Union Cloud, and it's the same core Flight software plus other features like contextual, I would say, or task level monitoring, observability, and role based access control. So it relieves you from the all the burdens of infrastructure management. So feel free to check it out. Request the demo. It's available now. Cool. So in terms of deployment paths, I would say that the first step, and probably many of you are already familiar with this option, is what we call the sandbox. And there's some confusion out there because there's still a command Flight CTL sandbox start, but that command is kind of old. It probably will be deprecated soon. So right now, if you want to invoke the sandbox, you should just issue a Flight CTL demo start. The only thing you need is, well, Flight CTL installed in your system and Docker daemon running in your laptop or your system, right? It packages all the Flight components that remembered in the previous session. And if you're not able to join previous session, I'll recommend that you check it out in the Union AI YouTube channel. Episode number 4, it was a exploration the Flight components and the architecture of the system. All of those components are packaged in a Docker container when you use Sandbox. So it's good for rapid iterations, for testing, for demos. It's great. The thing is that it probably doesn't scale really well. You cannot scale out a Sandbox instance, for example, for to be able to run multiple workflows or large workflows is not the best option, and you cannot really. It's hard to productionize it. I mean, you cannot add some of the features we will see in a little bit, right? But for testing and demos is totally fine. or by validating, if you're just becoming aware of Flyte and you want to validate some of the assumptions or the ideas you feel about Flyte, you can totally validate it with the Sandbox versioning. Everything is there. Cool. Now, when you make some progress towards a more robust deployment, the next step is the single cluster deployment. With cluster here, we mean Kubernetes cluster, right? Right now, the substrate for Flyte is Kubernetes. And when we mention single cluster, we are talking about a single Kubernetes cluster. In this case, typically we use Helm chart for anything that is not Sandbox. Even the Sandbox is packaged on a Helm chart. So for single cluster, you will use a Flyte binary Helm chart, and as the name implies, all the components are packaged in the single binary, aka a single pod. Right? If you run the binary, and by the end of this episode, probably hopefully you will see the binary running on a live environment, and you will see only one pod, right? And all the components are right there. Okay. If you need to scale out all the if you take a look at the documentation, there's a page in the documentation that is optimizing performance. It has some of the ways you can take the core scalability of Flyte, which is very important, to a next level. And all of that you can do it with the Flyte binary. No worries of running everything in a single pod. So it's good for most of the use cases, and it runs on, I would say, any Kubernetes environments. I haven't tested all the environments, all the providers. No, that would be a lie. But I don't find any reason why it wouldn't run on different environments. For the most part, it just needs access to Kubernetes API. Probably when it gets tricky is when you need to interact with, for example, a particular blob storage option or particular auth provider. But the core Flyte functionality can run on any Kubernetes environment. Cool. So that's single cluster. And the next step will be what the Flyte documentation treats as a production environment. It is the same Helm chart, the same Flyte binary, but you will add ingress and auth. Um, yeah, the text, I don't know what happened with this text, but you can even scale out if you need. Yeah, so Ingress is basically a Kubernetes native resource that will let you expose the services in a way that is more scalable and probably cost effective than just using services, Kubernetes services, and using the load balancers for each service. You can condense everything in a single instance, in a single resource, which is the Ingress. And yeah, it's, I mean, production can vary depending on your organization definition of production environment, but we typically find that users, customers, consider production something that has scalable networking and it has authorization and authentication embedded, right? Otherwise, probably is not exactly a production environment, but it can vary. It can, the definition can vary depending on your policies. So yeah, it's the same binary chart, like binary chart, but you will add some additional um, resources. What we will do here in the demo is deploy a production single cluster environment from scratch. All right, and the next piece, probably the currently most advanced uh, or mature or robust form of deployment for Flyte is multi-cluster. Again, cluster here is Kubernetes cluster. So, for example, with single cluster, you can have multiple nodes, because there was some confusion. I don't know, a couple of weeks ago, I had a conversation with a user, and there was some confusion that single cluster was only for one node or for one physical machine. Now you can have multiple nodes, uh, and it's still considered a single cluster. For multi-cluster, we have different Kubernetes environments, and for this, you will need to use the Flyte core chart. And This is restrictive. Flight binary won't work for multi-cluster. With Flight Core, all the components run on separate binaries, separate pods. You will see it in a bit. I also have a multi-cluster environment available. And the idea is to separate the control plane from the data plane. This is optional. You can also you treat the control plane as data plane too. By this I mean, and probably we need to go back to the previous session where we explored the components on the control plane, which is mainly flight admin and the scheduler. All the logic, the idea lives there. And the data plane is where the actual workflows are reconciled into Kubernetes resources, right? So there was also a question this week during community meeting. Someone asked if they could run the control plane, for example, on EKS, and the data plane on GCP, for example, on GK. Again, I haven't tried myself, but I don't see any restriction why not, besides the obvious um, authentication authorization issues of handling different environments. For Flyte itself, no issue. I mean, the control plane will request executions to the different data planes depending on some rules that we'll see in a bit, right? So this is right now the main scenario for deploying Flyte. Obviously, probably the next step will be the managed service. You don't, if you don't want to deal with anything of this, there's the managed service, right? So those are the deployment paths. Let me see. Is there any comment, any question right here? No, I don't think so. Cool. So the next piece will be demo, right? So I'll start by the documentation. These guides are about to be updated. There's a PR right now in the works. You can find it in the repos in draft state, and it will be updating all of these sections. But you can see here different paths. And yeah, the sandbox is the simplest form. If I use config already deployed a sandbox, and you can see here that Christ, that all services are right there. The sandbox even ships with a Docker registry, which is very interesting, right? If you don't have a container registry available, the sandbox got you covered. It has all the dependencies right there. You can see here that it includes a Postgres SQL instance and a Mini instance for right there. But if you take a look, it's everything runs on a single container, right? It's a single container. Everything is there. And it's fine for testing and whatnot. Next thing is the single cluster, simple cloud. Well, simple is relative. Depends on what we consider simple, but I would say single cluster deployment. And there are some prereqs here and some general instructions. But if you want to take a closer look at these prereqs and the process of preparing your infrastructure for single cluster deployment, we have a couple of resources that are very different. One of them is this family of tutorials, Fly the Hard Way. All of this was, sorry, that's great. All of this was built with the community, with many users out there trying, testing, and helping us collecting learnings on these guides. So, for example, the Flyte on AWS, the hard way, goes through the process of doing everything almost manually, mostly manually, right? Probably the only thing that is not manual is the Helm chart deployment, of course, but the rest is it's mostly manual. We use a couple of scripts for the EKS cluster, for example, the EKS CTL. But for the most part, everything's there. So it's fine if you want to have some control, and if you're, be it your organization requires, of you're the type of person that learns by knowing how stuff works at a kind of deeper level. I think that this is the correct resource. It goes through the entire process, explaining everything you need for a successful production Flyte environment on EKS up to Oath. So yeah, completely production grade deployment. In this case, using Octa as a provider. I won't use this today because it takes a lot of time. So the next resource we have available for a single cluster deployment is this was released like a couple of weeks ago. It's a set of Terraform modules that help you prepare, basically do all this stuff automatically, and leaves your infrastructure ready to deploy Flyte, right? So the agenda, uh, yeah, according to the agenda, before will be the self-hosted option, but considering the time some of this process will take, I will start the deployment using Terraform, and once it's running in parallel, we will go back to the on-prem deployment, which is not very automated right now. Okay, so let's get started, and let me do this. I'm sharing my screen, so probably doesn't make much sense. So let's get started with the AWS deployment. So um, I'll start from scratch. Let me see. I have here an empty um, folder, and I will clone the repo here. Uh, right, everything is there. So we go to environments, AWS, and here let me show you here the TF files. So the next thing we'll do is we will follow the tutorial line by line, and yeah, we'll do it together. So the first thing that it says is go to provider TF and replace profile with your AWS CLI profile. It doesn't have exact instructions on how you set your AWS CLI profile because it varies depending on how your organization handles authentication authorization uh, through AWS. So we'll do it in a way that it's helpful for me. My organization uses single sign-on, so I verify the code and authorize the Terraform client. So I'll use my superpowers. Uh, I'll be deploying everything on EX West 1, and I'll be using um, yeah, an AWS CLI profile. So that's the first thing. So I need to probably I need to open code here. So I need to go to provider TF and change the name of my profile, right? Uh, it was here too, I think so. Yeah, cool. And the region, probably you're using a different region, but you need to change it here. Cool. And yeah, save your changes. Next step is create a S3 bucket to store Terraform state. Long story short, Terraform uses state every time you need to apply a change. It compares everything to the state that is stored, in this case, on an S3 bucket. So probably through the entire process, I will go a couple of times to the management console, but it won't be too much. I mean, the idea is not to use the console um, almost at all, right? So um, this is a prereq, so I'm not using Terraform for this. So I will use Flight School DF state. There you go. Pretty simple. The idea is that if you have some lifecycle policies for objects here, probably consider disabling them, or using a more relaxed lifecycle policy for TF state, because Terraform doesn't react really well if the state is rotated, deleted, etc. Okay, so Flight School TF state, and I go here and I change the bucket name. Uh, Flight School TF State. Cool. This is the region where the actual bucket lives. Just West 1. And that's it. I'll save changes. The next thing will be to go to DNS TF and indicate a DNS managed zone, the one that you will be using, right? So I'm assuming uh, you have something like that available. So in this case, I will use manage zone. It's available, right? The next thing will be you will need to define the fully qualified domain name that you will use to connect to Flyte, um, and put the first part of such a name here. So we'll use here Flight School, right? And the entire thing you need to change it here. I'm just using the steps in the tutorial. Not trying not to context switch so much. So the entire thing will be an demo.run in this case, right? There's a record here that you'll need to change, but the only way to know what this record is all about is once Flyte is completely installed. Once the Helm chart is installed, the ALB will create a load balancer instance, and you will retrieve that address, and you will be able to update this DNS or CNAME record, right? But right now, the only thing you need to do is to define the managed DNS zone and the FQDN you will be using to connect to Flyte, which is Flight School. All right. Okay. What else? Yeah. Okay. Yeah. Go to locals. This is important because all of the objects that these modules create will use a naming scheme that starts with project dash environment. So I will use Flight School TF, right? Save. And finally, I'll go to the RDS module. Again, as you probably remember or you already know, by now, Flyte uses a relational database, and this is the current config to deploy the RDS instance. So if you don't change anything, what will happen is that the Terraform module will generate a random password for the database, and it will use the Flyte admin and for the database name and also for the username. But if you need something else, if your organization needs something else, you can change the names here. You will need to change them also in the Helm chart. We will go there in a bit. And also, if you want to define a master password, you will comment this line and uncomment this line and define a password here, right? So you have control there. Cool. All right. Next thing we'll do is run a Terraform in it. Um, Everything should work. It's going through the modules that are declared, the providers that are declaring the files. And oh yeah, there's something else I need to do. Sorry, for my actual CLI to work. And cool. So there you go. Mhm. In the meantime, you can share in the chat if where do you plan to install Flyte? Is AWS your current infrastructure or cloud provider? Do you plan to run it on GCP or Azure, Oracle Cloud, on-prem? Just let us know in the chat. We are building resources like this to help you with deployment on other environments, not only AWS. But your feedback is as usual, appreciated. All right, so initialization worked. So the next thing is that we will do a Terraform plan, and I will save this in a file, just to make sure that when I run a Terraform apply, I'm invoking the same plan that was generated. So it takes some seconds. Cool. So now we'll do a Terraform and apply the flight plan. And all right, cool. So I will leave this executing. Typically in my environment takes about 12 minutes to run. So in the meantime, I will go through the on-prem installation. So where are these instructions? Well, it's not in the docs. It is again a community maintained tutorial, because especially for on-prem, you can only imagine the how diverse are the options for everything, and for the Kubernetes distribution that you may be using, for the blob storage, for networking, for etc. For example, storage providers, etc. So this little guide uses basically K3S, which basically deploys virtual machines, and we install. We'll use multipass. We install their K3S, which is a compact version of Kubernetes, and we use this to a install the dependencies, and b install Flyte itself, right? So it covers a single cluster, a single node, right? It I will show you in a bit how it looks like. If you need to add multiple nodes, mm, either feel free to contribute, or we are working on testing and expanding the guide to include multi machines, and also to make it even more automated. But right now, I will basically launch an instance, K3S master, 4 gigs of memory, 4 gigs of disk. And once this thing is up, I'll get the info. What I am interested in, I'm interested on the IPv4 address. I'll show you why in a little bit. Right, it's going through the process. This one is creating the EKS cluster. Cool. Great. So multipass. Info. I think it's info. Yeah. K3S master. Right. So here's the IPv4 address up and running. That's cool. Next thing that I'll do is basically um, execute this script inside the K3S master instance. It will install K3S there. Inside the VM, it will install K3S there, to be exact. And that's where the fun starts. I know there are tools out there to manage multiple contexts, multiple Kubernetes clusters. Again, this repo is called a hard way for a reason. We tend to do most of the things manually here, so you can see step by step. And because the thing with automation is that it's great, but it's highly opinionated. I mean, that includes these modules. These Terraform modules have many decisions made up front. You can change many of them, but if you have to tweak this completely to your environment, probably it will take you more time. So that's the idea with the hard way tutorials, to give you full visibility on the process, even when it doesn't look sexy at the beginning. Cool. All right, so I will retrieve the info from the K3S cluster. Okay, so I got this here. The CA for the cluster, and the auth info for the actual user, and the context. So what I will do is to basically edit my kubeconfig file to so I can connect to the cluster and do everything else, right? So um, let me do this. Home cube and config. Yeah, I trust this. Why not? Later. Cool. So the first thing that it recommends is that you will create a new entry, right? A new cluster entry right here. But you will change the IP from localhost to be the IP address of the actual instance. So this is this one. Okay, cool. The next thing that the guide mentioned is that they need to create a context, right? Uh, you will basically you need to assign a name to the cluster. There's a name here that is default, but it's better to use a different name, a more informative name. So I will use here K3S Master FS from Flyte School. So I will go now down here to the context section and I will add a new context. So yeah, the guide mentions that you should just use the same cluster name and give you can use a different name for the context, but in this case I will use mostly the same stuff. um, so I will create a new context, uh, cluster. In this case it's going to be k3s master fs. um, User, I will use the same k3s master fs, and the name for the context I will use basically the same. There's an indentation problem here. Cool. K3s fs. Okay, that's the context, the cluster, the user, and the last thing is to actually add the user. So there are multiple users here. We'll create a new one with the information that is here, right? The only thing that we'll need to change is again the name of the user, because default is not especially useful. So this name needs to match what we define in the context. So it's K3S master FS, and that's it, right? Oh, cool. So if everything is use context, I will say yeah, Flyte school S. Uh, yeah, why not use context? Mm, yeah. Let me see. K3S master FS. Ah, yeah, what's happening with my memory? K3S master FS. Cool. So it's there. It will have a single node. That's it. So we're inside the. Let me clear this. We're inside the Kubernetes cluster, a single node Kubernetes cluster that is running on a VM on our machine. In parallel, Terraform is still working, and we will deploy the Postgres and Minio dependencies here, and then we will install Flyte here, right? Why bother? Why not just running the sandbox if it's running on my laptop? Well, sometimes again for experiments, for example, for testing, etc., the sandbox is not enough. And this is just an example of how the process of deploying on-prem, probably not your laptop, let's say you have an on-prem environment, how the process will look like, right? So you will use probably K3S, you will have a Kube ADM Bootstrap cluster or some other distribution. So up to now, we haven't touched Flyte. So next thing will be to actually deploy the actual dependencies. So there's a manifest here that basically it's prepare. uh, to help you with the dependencies. Let me see, where are you? No. Oh, yeah, there's a good reason. Flight School episode 5. City code, sorry, to Flight School episode 5. Here, let's do curl. There you go. Where I should be. And code up. Cool. Let me show you real quick here. All right, the local flight resources. So these manifest. I don't know. Uh, it's again highly opinionated, right? It uses the local path provisioner. That's probably the main difference between, or the main point where you will need to customize this for different environments. It uses local path, meaning that it will consume storage from the node where it runs. But what happens if you have multiple nodes? You will need some form of shared storage. This manifest right now is not prepared for that, because again, for shared storage, and this shared storage will be needed, for example, for the database, and for hosting the actual, for example, the actual menu instance, and in shared storage. So it could be NFS, it could be another form of block storage. So there are many options there, and you will have to use the proper storage class for that. Okay, so again, in the near future, I plan to expand the tutorial to include multiple machines using NFS storage. But right now, it's local per node. Okay, the rest is it's kind of standard. It uses a persistent volume, so the actual data in your database will outlive the pod. The pod can even be destroyed, but the data will still be there. But the if the cluster is destroyed, well, yeah, the volumes will be destroyed, right? Okay, and it has a service for exposing Postgres, and it's opinionated in the image it uses, and in the authentication method it uses for Postgres. It also runs a mini instance for blob storage. Yeah, not great. It has the credentials right there. Um, but this is a way, not the best way, but this is a way to actually deploy the dependencies for Flyte. So okay, so we will do an apply on the local Flyte resources thing. Yeah, this is in the guide, no problem. You need to create the Flyte namespace. Um, right, yeah, there will be one resource that is unchanged because the storage class is not namespace. But the rest of the things are there. So if you take a look at the pods in the Flyte namespace, it's creating Postgres in Minio, and it should be running before you attempt to deploy Flyte. Okay, it's there. So let's go back to the tutorial. Yeah, you need to create the Flyte namespace. Okay, so yeah, there's an option here, but it's not really, doesn't make much sense now, because with the Flyte binary chart, you don't need to have you don't need to put the database password in plain text right there in the Helm chart. We will use this feature for the production deployment in some minutes. I hope so. I hope we have time. And but for the on-prem deployment, as you saw, the manifest is very opinionated in the Postgres authentication, so it won't use this secret. But we will change this in the short term to make it even better. All right, so now we will download the Helm values file. Let me see. Okay, now Minion Postgres are running. Cool. Again, the local values. This is Helm values file that has everything by default. I mean the service name, the credentials, the metadata, data container, etc. Everything's right there. So if you just install, let me, yeah, install the Flyte binary. The only difference is that you will use local values. Um, it should work right out of the box. So the init container is working. The first init container in the Flyte binary chart is the one that connects to the database and validates that the connection is successful before trying to run Flyte. Cool. Yeah, in parallel. In the meantime, um, yeah, Terraform is done. So it's configured to output the information you will need for the actual Helm installation or the actual Flyte installation using Helm. So great. If I go back to the tutorial, right, we are at this point. So we will switch the context. Uh, it still work. We will switch the context to the new cluster. It should be just Flyte School. Uh, Let me see. It's project environments. What did I use for this? Um, this is locals. Yeah. TF. Sorry. Py-school.tf. Cool. It's there. So it has already nodes deployed, but it even has some nice thing in my opinion. Which is, for example, the ALB, the AWS load balancer controller is already in place. So when I try to install Flyte using Ingress, it should reconcile and create the load balancer automatically. So the next thing that the tutorial will ask you to do is to create a secret for the database password, and we will do this. So if you take a look, the master password of the database is there, but it's sensitive um, field. So we will, or sensitive variable. We will output this here directly, and we will use it to basically create a secret. um, where are you? Database secret.yaml. It's right there. Mhm. There you go. So here I will set the database password that's in the output right here without the quotes, and save. Next thing will be to basically apply. I prefer create for new resources, and uh, Christ, again, yeah, this is again a new environment. The Flyte School TF running on EKS doesn't have um, the namespace Flyte. Should I automate this? Cool. The secret is there. So the next thing that we should do is to download, add the repo, already add this, and download the values file, which is here. The instructions are there. So I will, again, as promised, I will run through the entire process with you. So EKS production is here. So first things, um, everything is in the guide, but you need to add username Flyte admin, because by default the chart uses Postgres. And remember that in the Terraform module we defined that the username was Flyte admin. You can remove the password field because we will use a secret for this. For the host is the writer instance for the RDS cluster, and it's here, the cluster endpoint output. It's right there. The database name, remember that it was defined as flight admin. The metadata container, you can use the one that was these modules just create a single bucket, right? You may very well have your data running, living somewhere else. You will define here the that bucket, but right now I'm using the same bucket for both metadata and the actual data to be processed. The region where this bucket is living, cool. I will disable oath right now. I don't need it. And yeah, the instructions, probably a good PR will be to make this chart or this values file less opinionated, because it enables Spark by default, and many times you don't need it right away, at least. There are other things that you need to add. Everything again is in the tutorial, but for example, you need to add this to this section. The purpose of this is that for the proper IAM role annotations to land on the pods when Flyte execute tasks, right? Those tasks will need access to Amazon resources. They will need role annotations, and this piece basically helps automating that. I forgot one important field under configuration, which is the inline secret ref. Right? This is the reference to the secret again for the database, and this is the one we just created. Um, so yeah, okay, cool. All right, what else? Yeah, the ingress. Again, the values file, it has some annotations for Nginx, but in this case, we will use um, the Amazon load balancer controller. So basically, I'm replacing the whole section with ALB annotations, and there are some things you need to change. For example, your certificate ARN. There's one thing with the certificate that I still need to check because it requires us to go through the console, and I don't like this, but that's the current status. Uh, so you're better off knowing this. So you need to go to the certificate manager in the correct region, and you can find your recently Terraform created certificate pending validation, right? And the only thing you need to do is to hit create records in Route 53. He will create the records, and I don't know, 1 2 minutes after the certificate will be issued. I need to automate this, so you don't have to do it. But for now, I mean, I can take the ARN and add it to the values file. Um, and the other thing you need to change is the FQDN you will use to connect to Flyte. In this case, remember that it was Flyte school.union demo.run, right? Cool. And finally here, for the service account, you will use here the binary role ARN, which is here. Okay. There's one more thing that probably I missed here, and that honestly I don't see here. I don't know why. Is the basically the annotations um for the actual bots that will run there. Let me take a look at this. Probably, yeah. This is an inline, um, and I don't know why it's not there, but Yeah, let me wait. Yeah, add these two sections. Two of them are covered in the tutorial again, but I'm not sure why they are not in the actual file. So yeah, mm, oh yeah, there is. Cool. Uh, that's resources. Close to resources. Yeah. Let me see. Cool. So the first section is task resources, completely optional. But if you want to define platform-wide defaults for how much resources can flight task request and the limits, especially the limits for request, you can define it here, right? I'm using this just to prevent out of memory situations when a task or even an example task probably may crash. I've seen this in the past, so I try to use this as a way to prevent that behavior. And a very quick Flyte can help you manage your code using a kind of a GitOps approach with different environments, development, staging, production, and each one of them will be a different namespace in Kubernetes. And for each namespace, depending on the environment, you will need to have access to different resources on your infrastructure. You could use different IAM roles. In this case, I will use the same for the three environments. But this is where you set the role that will be automatically used by any auth that results from a workflow execution. Okay, cool. All right. So I think that's it so far, I will say. Let me check back on the status of the certificate. Um, great. I love you too. Yeah. So the DNS records are there. You can see here that the first one was created automatically. Um, you can see that Flight School. It's right there. These two, right? So certificate should work. Yeah. The thing is that if I install this right now, the ingress won't work. I mean, everything else will work, and we will need. If we run out of time, I will deploy this without ingress, and we will do a simple pull forward. That's it. But and yeah, basically, I will issue a flight binary installation, and that's it. In the meantime, let's go back to the um, local. Yeah, I think I need to. Sorry. Kubernetes use config, use context, master. Okay. Get pod. All right. Great. They need. They need. Yeah. No matter how much times you run this beforehand, it can fail. Enable unmanned volumes and attach volumes. Time it out. Waiting for the conditions. Yeah. Not sure. Get PVC. Uh, PVCs are bound. So not sure what's happening here. What change on the actual local values? Um, yeah, I don't think that anything changed. Pretty simple. So yeah, it's weird. Okay, but yeah, the next piece is basically running the helm install flight binary to this environment. That's it. I mean, it's right there in the fly the hard way tutorial. The next thing will be to run a install flight binary, and we will need to run because this version of the on-prem deployment doesn't include ingress. We will need to run three port forward sessions. One for Minio, because when you register and run a workflow from your CLI, it needs communication to your blob storage. So you will need a port forward session from your laptop to Minio, and one for gRPC, which is the backend API where you connect to compile workflows, and HTTP for the UI. And this is the Hello World um, workflow, and it works. Yeah, this is proof that it works on um, local host, right? Let's see what happens here. Great, thank you. Much love. So let me install on right now on AWS. Let's go here. Uh, AWS. Cool. Right. So Helm install Flyte binary, but we will use here the EKS production. EKS production YAML file. There we go. What's happening right now is that the Helm is rendering all the templates and validating this with the Kubernetes API. And if it says deployed, it's because at least the YAML was correct. And if you take a look at the pods in Flyte, uh, you will see a single binary uh, running or trying to run. I like this. Cool. I will follow. Yeah, it's getting started. Cool. Ah, ready. So right now, Flyte binary is ready. Probably we don't have an ingress address, right? There's no address because, as I mentioned, for some strange reason, certificate is failing to be issued. This is totally a non-Flyte thing. And the many times I tried this, the only thing that was needed was create the CNAME missing CNAME record there. But yeah, I don't know. But we can get the services. Right now it has two services, one for gRPC, one for HTTP. Yeah, thank you. It's taking some time. But in the meantime, is there any question? I can't see. There's a comment. Our primary cloud is Azure with the hope of migrating to AWS in the future. Thank you, Chris, for sharing. Yeah, right now, I mean, we have mm, there are some users in the community, sorry, who are running Flyte on AWS, big and small implementation, and AWS using again Azure Blob Storage, using Azure AD. And we have right now a working group. There's a channel on the Flyte Flag, WG-Azure. And there's some experienced folks trying to improve the way Flyte runs there, and so it's kind of easier. Uh, and the next thing we will be doing is try to again do the same thing we did for AWS with these tutorials, which is basically gathering the knowledge from the community. We'll do the same for sure. Um, so there are folks out there who have gone through the process, and we're happy to help. Right, so I will do a pour forward session right now with the Flyte binary HTTP, for example. And right, if I go now to localhost, I will find there the console alive and kicking in, right? And yeah, if I run, for example, binary gRPC thing, well, I could expose the gRPC API, but workflow execution probably won't work well because it will find a mismatch between the certificate, which is created at least for Flyte, school, demo run, that run, and localhost, right? So this is prepared for basically for production right now. Oh, yeah, the certificate is there. So um, I think we need to roll out the ALB deployment ingress. Oh no, address is there. So yeah, we're running out of time. I will do this real quick. So here you will get everything is in the tutorial. Here you will get the address from the ALB. You can update. Remember that we created this CNAME, but it's not pointing to anything useful because we didn't know the actual address. So you can now update. You can go back to dns.tf, uh, change this value, right? And save. Right? You can do a Terraform refresh and then Terraform apply. Yeah, I can just go there to the Route 53 console and just copy paste, right? Uh, I'm just trying to avoid access to the management console at all, and just show you that everything can be updated using Terraform. And so once, yeah, in Terraform apply, right? And once the actual DNS entry is updated, because right now it's pointing to entry example.org, Flyte school. There you go. Change me. Yes, please. Change me to the actual value that we need. And once that is done, the only thing we need to do is to um, update our local flight config file to make it point to the actual FQDN. And that's it. So let me see, do we have an actual forward session running? No. It takes some time because again it takes some time for the change to be applied. uh, right, the value is there. It's been updated. Cool. So I will go to home at config, and I will change the endpoint to be flight school .in demo. Insecure false because we were using a proper certificate, and that's it, right? So I will go right away to a place where I know I have an example, the same example workflow that is in the tutorial. I will run it against the newly created instance, and if it works, yeah, it will point you to the it will tell you, yeah, you don't need to use this now. You can use union demo. You can use now your actual URL. Oh, sorry, it's /console. um, Go to the development um, domain, and you can see this workflow has 3 tasks, and it started running, and hopefully it will run without any issue. All right, I think we ran out of time. I think we covered a lot. Again, the on-prem deployment has many things again to be improved, but that's kind of the general idea. There are some dependencies. There are many things there are many ways to configure data persistency, and once your dependencies are in place, which is basically Postgres and some form of blob storage, you can install Flyte binary. We have users right now consuming Flyte core, I mean running multi-cluster on-prem. So no issues. Let me show you real quick. Yeah, well, I have a multi-cluster deployment, but I'll better off show you the docs, which are about to be updated. And yeah, probably the best thing will be to show you the actual updates to be applied. I hope you're still with us. If not, you can watch the recording. Yeah, let me show you right away. Uh, the changes to be applied and multiple Kubernetes cluster is basically this. You will have a control plane cluster, which could be also data plane cluster if you need, right? You could also run workflows there, and you can have one or n data plane clusters, kind of headless clusters with no control plane running. That's exclusive. And users, administrators can define using basically labels. They can define what the behavior what's the behavior the behavior they want on the platform. For example, I want team A to run workflows only on cluster one, but other teams could run workflows on different clusters. You can even define weights for clusters that are preferred above others, and that's from the administration point of view. And users can just use labels on their executions, and the control plane uh, will run the actual workflows on the data planes depending on those rules, right? So the whole process is here. This is kind of, yeah, the most advanced um, way of deployment right now. Probably will need a follow-up session for multi-cluster and again for deployment on other clouds. All right, so I will stop sharing my screen. Is there any question out there? Um, is there anybody out there? Yeah, no questions. Let me again see. Can you talk about how to think about EKS manage node groups and how they interface with Flyte task workflows? Yeah, good question here. The actual modules, the actual Terraform modules have some decisions. Let me stop sharing my screen. Have some decisions made upfront in terms of node groups for um, different executions. You can use, for example, pod templates, and this is a way to basically map different node groups, for example, for spot instances, for GPUs, etc. uh, and with this, when they are matched for these labels, executions will land on different node groups. The again, the Terraform modules are prepared, and they actually prepare and create different node groups. Let me show you real quick. And from the user point of view, you could use, for example, pod templates to control placement on different node groups. Yeah, it has different node groups for spot, GPUs, on demand, etc. And you can control this from the user point of view also. Mhm. I don't know if that answered your question, but we can uh, sync on the Slack and continue a conversation if not. Cool. Um, yeah. Anything else? Any other question? No. All right. And yeah, to my pleasure. And to our eyes pleasure, everything succeeded and it's working. That was a live deployment on less than an hour on AWS. So I hope all of this was useful to you. Again, there are many ways of doing these things, but we are trying to create resources that help you focus on what matters. I understand how data scientists couldn't care less about infrastructure, so we are trying to build resources to automate the entire process and let you focus on what matters to you. All right, thank you all for joining, and hope to see you in the next episode. Goodbye.